Okay, so this is the first example. Let's get rid of it. What I do is I just hide the toolpath here, and I will hide the part itself. Now you see I've prepared a lot of parts, and I suggest that we just go through the parts one by one, and then I will explain different parameters at the same time. Let's get the next part, part number 2. Oh, actually it's like 2 parts, but we will get to this later. Let's concentrate on this part here. What I do now is, first of all, I rename this, let's say part 1, that's a good name, and duplicate the operation. So now we get a copy of operation 1, which contains the same parameter set. So there's the same settings, same subover, same stock model, same floor, and same wall surfaces. So what we gotta do is, first of all, we need to make the reselection of the surfaces. So let's do this. Go to the settings, we keep the same tool, we keep the same feet and speeds, and also we keep the parameters here on the surface paths page. What we gotta change is the part definition. First of all, the floor surface. In this case, and as you can imagine, is we would like to machine the area between the two walls again. But in this case, the floor surface is curved here. And let's see what the system calculates out of this. So let's make the selection here. This is the floor surface I would like to have selected. Then we select the wall surfaces. As you remember, we select always the full part because we would like to have collision checking and the area to be machine defined with this. Let's confirm. We also keep the link settings constant at the same, so we don't make any change here. And what we have to do is we have to replace the stock definition. So go here, click this button, and then make the stock surface selection. Let's hide the part number 2 and call this layer here. So for my stock definition, I've prepared this part, which is basically the stock definition according to this part. Confirm it, and hit OK, and hit OK. Good. Let's hide the stock level layer and bring back the part, and let's calculate the toolpath. So you remember that for the first part I said that the tool orientation is aligned according to the surface normal of the floor surface. So when we look at the first toolpath, the floor surface was a horizontal plane. According to that, the tool axis was normal to the floor surface, which means it's a 3-axis toolpath parallel to the z-axis. Now in this example here, it behaves slightly different, and when I show you the toolpath, you can see that now the toolpath is aligned to the geometry that we have selected. And as we run the backplot, you will also see that the tool axis is aligned to the floor surface that we have selected. Okay, so that looks very good. Let's make a small verification. So I would like to make material removal. Let's hide the part number 1 and part number 2, and let's get part 2 stock definition. And now I make a simple selection here of the stock that I would like to simulate with my cutting simulation. I just select this, apply this, hide the stock, and now I got my material removal activated, and I just can run the simulation. Let's make it a little bit slower, and then you see how the material is being removed for this pocket. You can clearly see the surface, the curved surface, and the tool according to the floor surface. Let's do it again. Okay, so these are the cuts, and you see that you get a nice clean result for the roughing for this example.